Quiet, por favor. All right, guys, so today we're going to be dividing polynomials. You've probably seen this in your Algebra 2 class. It's kind of tedious, but it's not that bad. They're just long problems. Why are we learning division? Well, we're learning division because factoring polynomials is very important. Factoring helps us to solve equations. It helps us to graph. It helps us to, yeah, that's pretty much it. So, but that's kind of what you do with equations, right? You solve them and graph them. So without factoring, you're kind of in trouble. And it turns out that division, dividing polynomials, helps with factoring some polynomials. Last Friday, we started factoring. Now, I think we need more practice with the basics, so I'm actually going to throw a day in sometimes where we just get to practice basic factoring on your homework again some more. But that aside, that's basic factoring. We're going to be taking it up a notch to polynomials that have a little bit more involved where, you know, your basic box method, GCF difference of squares isn't going to cut it. And that's where long division and synthetic division come in handy. They help us break polynomials down to smaller chunks so that our basic strategies will work. So, to make a long story short, today we're learning about dividing polynomials. Why? So we can factor. Why? Because you can't really do anything with polynomials unless you can factor them. So, that's our goal for today. Like I said, you've probably seen everything I'm doing in today's lesson already. Nothing new, probably. Doesn't mean you're going to remember it, but when I show you, you'll be like, oh yeah, okay. All right, you don't need to write this. This is just for review. Now, I know you guys know how to do this, or maybe you don't. But if you do, I included this because it's supposed to help you connect something that you already know to something that maybe you're a little bit rusty with and you realize, oh, it's not that hard, it's really just the same thing. So let's start with something simple here. First of all, if I wanted to divide these, which one goes inside the bracket?
684.
Not just because it's bigger, but because it comes first. That's how it works. And the 5 comes out here. Now, the first thing you do is you ask yourself, what would you multiply 5 by? Well, let me rephrase that. That's how I'm going to say it most of the time today. But today I would ask myself, how many times does 5 go into 6? 1 time. And then you multiply these. 1 5 really makes just 5, right? But what do we do with that?
Add a 0. 0. Oh, you move down to 8.
No, you subtract it.
You subtract it. There's different ways of doing it. Maybe you guys are right. But for now, say just subtract it. What do you get? 1, and then you drop down the next number. And then you continue the process. So how many times does 5 go into 18?
3.
And what am I going to put? 15, and where? Because 3 times 5 is 15, right? And that goes right here, and we subtract. So it's a 3-step process, and then it's repetitive. So how many times does it go in? Multiply, subtract. How many times does it go in? Multiply, subtract. How many times does it go in? Multiply, subtract. That's the process, right? So here we get 3. We get to do it one more time. Bring down the 4. How many times does it go in? Multiply, subtract. We could go into decimals, but here's how we're going to do it today. We're going to write our answer like this. What's the answer for 684 divided by 5?
136 R4.
You could say 136 remainder 4, right? But what's another way to write the remainder? You could, but we're going to do a little bit different today. You take the remainder and you put it over the 5, the divisor. Okay? So it's this number and then this number over this number. So 136 and 4/5. And then we're going to be sneaking a plus in there today. But that's okay, because don't you guys agree that 3 plus a half, that's really the same thing as just 3 1/2?
No.
Well, it is. Now you know. All right, so this is something that hopefully we're all kind of familiar with, and I hope you got the process. How many times does it go in? Multiply, subtract, repeat. Okay? And that's exactly what we're going to do, but we're doing it with polynomials today. All right? So let's begin. Go ahead and write down example 1. Okay, so as I write this, guys, the one that goes on the inside is the big one. So, Joel, what was the big one?
Never mind the folks.
It's less 3 minus 8x minus 6.
What was the last number?
Minus 6.
Thank you. Okay, so the one that comes first goes inside, and then what was the other one? Was x minus 1 or
X plus 1.
plus 1? Okay, so there's that. Okay, so we're going to go through the same process. How many times does it go in there? And then multiply, and then subtract. Okay, now the one that's the most different is that first step. How many times does it go in there? So what all we're going to do is we're going to compare this number to the first number here. So I could say how many times does x go into 6x cubed, but I'm going to say it a little bit differently. I'm going to say, what would you multiply x by to get this?
6 squared.
6x squared. Because if you multiply it by 6x squared. Now, I mean, another way you could do it is you could just divide them literally, like on the side, 6x cubed divided by x, and it's going to be 6x squared. But I think it's just kind of easier to think, what would you multiply this by to get that? And the answer is 6x squared. And that's the first thing we do. That's our first step. How many times does this go into that? Or in other words, what would you multiply this by to get that? Okay. Then what do? You missing it. After we put it up here, we multiply it. So you're going to take this and you're going to multiply it times both of these now. And where am I going to put that answer? Right underneath of it. Okay? So what is 6x squared times x?
6x.
And what is 6x squared times 1?
6x.
Now this next part really confused people, so bear with me. It's I don't know why it confused people in my first group, but they were a little lost on this. So, three-step process, right? How many times does it go in? We got that. Multiply, we got that. What do you do last? Subtract. Now I'm going to subtract this whole thing all the way across. And what that's going to do is it's going to change the signs. You guys good? So this one's going to become a
Negative.
and this one's going to become a.
Negative.
What if it was already negative? Because when you subtract a negative, it really becomes plus, right? So you just change the sign. All right, now we add down, right? Or combine. So what's 6x cubed minus 6x cubed?
0.
Gone. That should happen every time. Your first term should go away. And then what is 3x squared take away 6x squared?
Negative 3x squared.
Bring down your next term, right?
Negative 8.
Negative 8x. And then after that, we
Do it again.
repeat, right? So let's do it again. This time, instead of asking, what do I multiply x by to get 6x cubed, now I want to know is what do I multiply x by to get that? What's the answer?
Negative 3x.
Negative 3x. After we find out how many times it goes in there, what do we do with this?
Wait, why negative? It's positive.
No, it's negative. Because when you add the check sign, it said negative.
So you take this and you divide it by that. And you're left with negative 3x. Now we multiply that times both of these, right? 1, 2. And that gives me what?
Negative 3x squared.
That will cancel out.
Negative minus 3x.
3x. Okay? That's because there's a third step, Rami. So after we multiply, what do? You subtract, which means we're going to change the sign. So boom, boom, right? Cancel. Negative 5. Now what? Bring down the 6. Okay, we get to go again. All right? So now I want to know what I would multiply x by to get what? Negative 5. And what's the answer? Negative 5. Now I'm going to multiply this times both of these. What would I get? It's not hard, it's just tedious.
It's a long problem.
Now what do we do?
It makes it really like, did you change
I did it.
Yeah.
Bailey, I did it.
Change the signs. Cancel. Negative 1. Now that's our remainder. Okay? Now just so you guys know, how do you know when to stop? Well, you're not necessarily going to stop as soon as you have just a number, because sometimes you'll stop before that. You know when to stop whenever the power that's here, like let's say I had x squared, if that power is less than the power up here, that's when you stop. Okay, but you'll see an example like that later. But for now, we stop there. But that's not how we're going to leave it, because we need to know how to write our answers. Just like we said before, it's going to be this thing as our answer, right? So let's write that. Negatives, was it negative? That's not a negative. That was a smudge. Ignore that. So it's positive 6x squared. And then we do plus, right? And you're right. We do the remainder, which is negative 1 over the divisor, which is x plus 1. Now, just so you guys know, anytime the number on the top, the front number is a negative, what they might do is take the negative out and write it like this instead. Take the negative off and drop it down so it's minus. They could do that. They probably would, honestly. But there we go. So that's long division of polynomials. It's exactly the same as traditional long division in terms of the steps and the ideas. It's pretty much the same thing. It's just uglier.
Yeah.
So we're going to do a guided practice, so we're going to take it slow, and then we'll let you guys do one completely on your own. Ready?
Oh, Bailey, I'm not confident yet.
That's what the guided practice is for.
Plus, let's make sure you're confident. Oh, this is what you were talking about.
Copy this down, please.
Oh,
That you might not have expected. So something that you might have noticed, and it wasn't a matter of coincidence, or it wasn't a matter of, oh, it's always going to do that. I don't know if you guys realize this or not, but did you notice how every time I'd work this out, every time I put them down here, it just so happened that the like terms were lining up?
yeah.
That wasn't coincidence. It was engineered that way. Now, here's the issue. On this problem that we're looking at right now, unless we do a little something, that's not going to happen. Do you guys see how there's a missing term here?
Yep.
Which one is missing?
X squared.
The x squared, right? It goes 5, 4, 3, 1. We need to put it in there. Now, here's how you put it in there, okay? So let's write this. We're going to rewrite the whole thing. But where the x squared should be, what I'm going to do is I'm going to put 0x squared. Okay? That way I have an x squared there, but it's still nothing, right? Now the same thing applies to this. What term is that one missing? It's missing an x. It goes from a power of 2 to nothing. It should be 2 and then 1 and then
That
none.
makes sense why I couldn't get past the first one. Come on, Bailey, you're supposed to be my like interest.
Okay, I think we're ready.
Why did you not lead with that?
Huh?
Why did you not lead with that? You just let us start working on it.
I didn't. I said this is a guided practice. Wait for me. But I'll tell you guys what to do. If you ran ahead, that was your choice. Now, we have x to the 5th. Help me out.
Minus 3 x plus 2x cubed plus 0x squared plus x squared
Just, okay, 4x and then 9?
1.
1. And then out here we have x squared. I remember this one, 0x minus 1, right? Okay, so now here's what I want you guys to do. We're going to be putting something right here. I want you guys to see if you can figure out what it is. I'll give you a few moments. See if you can figure out what goes right there. You know what it is? Just a second. All right, Cece, what goes there? It's x cubed. Why is it x cubed? Because we ask ourselves, what would I multiply this by to get this? And the answer is x cubed. Now you guys are going to be putting something right here. See if you can figure out what will go right there. I'll give you a few moments.
See, this makes it a lot less confusing.
Uh-huh. Bless you. Is Giovanni Perez here today? I didn't see him. All right, let's try. Isaac, do you know what goes here, bud? Huh? Good. So you're going to take this and multiply it times all three of these. 1, 2, 3. And that's what we put there. Okay, now, this one I'm not going to give you much time for. I'm just going to ask you, Joshua, what do I do now? Yep, and that just basically means go through and change all the signs. Something needs a different color here. So change, change, change. And now we go ahead and combine down. So I'm going to call on someone to help me out with that. So Alan, what's x to the 5th minus x to the 5th? Yep. How about here? Good. And then how about here? Good. And then, yep. Okay. Yeah, bring down the next one, which is 0x squared, and then we repeat. So, I want you guys to see if you could do all three of those steps. Now you're going to need something here, here. Don't forget to change your signs, and I want to see what you guys get, so go ahead. All right, Hassan, what goes down here?
Negative 3x.
And then?
Negative, no, positive 4x to the 3rd.
Good. And then?
Negative 1.
No. So this times this gives me that, right? This times this gives me that. And now we do this times this. So what's negative 3x squared times negative 1? It's positive 3x squared. All right. What do we do next, Kevin? Yeah, you're going to change all those signs, right? So here we go. So it's going to be plus now. Minus, doesn't really matter. It's 0 anyway. And then minus. And then we combine down. So if we do that, Jonathan Herrera, what goes here? And here. Okay, try again. We're still not done. So now I want you guys to do the next one. We just completed another cycle. Now go again. We want to find out what we multiply this by to get that. Yep, I made it long on purpose because I know you guys need to practice it repeatedly.
Plus 6x.
No. Good guess, but no. Let's try Tristan. What goes here? Huh? Okay.
Mr. Bailey?
3x? I agree. Because 3x times x squared would give me 3x cubed. Keep going.
Don't you have to bring down the 4?
Okay.
The Kalen Smith, sorry.
Oh, okay. Alright. So, it's 3x cubed right here. And then 0 at the second. Alright. And then, negative 3x.
Okay, then we know we're going to change all them signs to subtract, right? Dylan Lee Bryant. What goes here?
I'm telling coach.
Plus 7.
Okay. Let's do the last one. Hopefully you guys have gotten a little bit. I don't want to spend too much longer on it. So Sophia, What's going up here, Sophia?
What is this?
It's your homework.
All of it? Yeah.
Huh?
Good boy.
-3, I like that. Good. Because that's what you'd multiply this by to get that. Continuing on. Ishmael, what goes here? Next. 0x, and then last? +3. Change all your signs. This goes away. This is 7x. This is -4. Now we're actually done with this one. Now here's how we know we're done. You guys ready? What's the power of this one? What's the power of this one? When this power is less than this one, we're done. Okay? So my final answer would be x cubed minus 3x squared plus 7x minus 4 x squared, and we don't do the 0 in the final answer. That was just as a placeholder, so all of our terms would line up. There you go. That's long division. So I'm going to let you try one more on your own, completely, from beginning to end. Okay, here you go. Student practice. Before you begin, make sure you make all the terms there. We're missing something in this first one, right? So you need a 0 in there somewhere. Different type of problem. All right. So I'm going to say the answer. 6x squared plus 6x plus 9, and then you have a remainder of 8 over 4x minus 4. All right, we're going to move on to our next topic here. There is. You'll be glad about this topic, though, because as you guys have noticed, it's very tedious, right?
Yeah.
So what I have for you guys is a shortcut, but the shortcut only works sometimes, and I'll tell you when. Write this down, and I'll tell you, but go ahead and write this down real quick. I'll give you a second. So guys, here's the deal. This is called synthetic division, okay? I teach long division because long division always works anytime you're doing polynomial division. But really, we're going to be using synthetic for the rest of this chapter because long division is just tedious. And for what we're really going to be using it for, synthetic always works anyway. But there are exceptions. Synthetic will only work when the thing that you're dividing by, the divisor, is x followed by a number, and that's it. If it's x squared, it's ruined. If it's x squared plus 2x, it's ruined. It's got to be x and then a number. If you have that, you can do synthetic division, okay? So, first of all, synthetic division works very much like the other division, but I need to calibrate my pen real quick here. It works the same in that we need to have all of the terms accounted for. So, for instance, are we missing any terms in the polynomial here?
Yes.
We're missing the x squared. So let's start by putting a 0x squared in there.
It's not a 5x squared, it's 5x squared.
Oh, thank you. And the second one's not missing anything. Now, I'm going to show you guys some synthetic division. Much faster, much less writing. Okay? But you got to watch, because if you miss it, you're gonna miss the beauty of it. Ready? So first of all, I like to start like this. I like to start with this bracket. It's like the same thing as a division symbol, but upside down.
Oh, yeah.
Yeah, there we go. Then what you're going to do is we're going to put all the coefficients, not the letters, just the coefficients at the top here. So 5, 0, -3, and 1. Okay? Next, underneath the 1, I'm going to put another little bracket there. We'll explain what that's for later. Robert, you can't learn that. Next, this part you got to remember. We're going to put a number out here, and that number is this one. So I would circle that if I were you, and I'd draw an arrow. And then I want you to change the sign. So it's a -2, but I'm going to put a +2 there. That's your setup, okay? So you have a bracket here, a bracket here. All the coefficients go here. Don't forget, if you have a missing term, to put a 0 there. And then you put that last number there with an opposite sign. That's just your setup. Now we get to actually do the problem. Here we go. The steps are the same. Down, multiply, repeat. Add down, multiply, repeat. Add down, multiply, repeat. Ready? Add down, multiply.
Oh, I remember this.
Put your answer there. Multiply there.
But I don't remember him finding it from that.
Okay? Repeat. Add down, 10. Multiply. No, 2 times 10 is 20. Then repeat. Add down, multiply, -34. And then repeat, we're going to add down. What's that going to be? 35. Now we stop once we get there. Okay, so it's add down, multiply, repeat. Add down, multiply, repeat. Okay, now here's how this works. This number over here in the bracket, that's always going to be your remainder. This number here is always going to be your constant, which means it doesn't have an x with it. The one that comes after that will be your x term. The one that comes after that will be your x squared. And if there's more, it would be x cubed, x4, and so on. So here's my final answer. Ready? We have 5x squared. 5x squared, right? Plus what? 10x plus 17. And then my remainder is
Plus
35 over my divisor.
Minus 2x.
Just x minus 2. Whatever. Whoa.
That's so
Much easier.
So we could have done that for the
First problem.
before.
We could have done that for the first problem today. So anytime your divisor is a simple binomial, x and a number, you could do this. Yeah.
So what are the cases that we can't do?
If it's not this. Like if you don't have x and a number. So like if you had x squared plus 2, that's no good. It's got to be x plus a number. It could be, so, yes, yes, no. Yeah, so anything other than a simple and this, there's a way to do this. I'm not going to teach it though, but you don't want a number here either. So, all right. Okay, ready? Write down student practice 2. Here we go. I'm going to be asking Taekwon. Taekwon, I want you to tell me what goes on my top row here. Tell me them. Read them to me. What kind of 20? Did we have any missing terms? You got to be careful about that. We're okay. No missing terms. All right. Next, I'm going to ask Carlos. What number goes out here? Very good. You remember, it's this number, but the opposite sign of that number. Okay? Let's continue. Isabella. What do I do first? Bring down the 2. Good. Anaya Patterson. What do I do now? Where's Patterson? Is she gone? She's dead. Okay. Let's try Dylan Smith. What do we do now?
What?
What do I do now?
Oh, multiply -6 and 2.
That's -12. Where do I put it?
Right underneath the 9.
Good. And now we repeat, right?
Bailey, I'm working ahead of you. You're too slow. You need to speed up, Bailey.
I forgot my bracket. What's
Bailey.
this? 1, 11, -11? Okay. Write your answer. Plus 5, right? Close. Negative 11 over x plus 6. Yeah, it's 11. There you go. So that's synthetic division, much faster. And the good news is that's really the one that we need to know to do the rest of our chapter. Long division's cool. It works more often, but it's a little bit more tedious. All right. I don't know if we have time. If you guys want to try one more completely on your own. We actually have a solid 8 minutes, so that's definitely enough time. So why don't you guys try one?
All right.